Hey there, are you in 10th standard and struggling to understand the first chapter of Science 1, that's Gravitation? In this particular video, I have elaborated the Kepler's law in detail. Hi, my name is Professor Miithyl Dave and welcome to MD's World of Concepts. Let's get started to understand the various Kepler's law. Alright, so before we start with the Kepler's law, would you like to have a module which will help you to understand the summaries of all your Science 1 and Science 2 chapters in a much easier manner? It's like you need to just understand that video, and that video would cover the entire chapter of your textbook in a single go. Also, you also have the freedom to watch it wherever you want and whenever you want. If yes, and you would like to know more, just check out the link in the description below. Alright, so now let us start with the Kepler's laws. Kepler's law. The topics covered are introduction, the first Kepler's law, the second Kepler's law, and the third Kepler's law. So let us first understand the introduction. So in the early 1600s, Johannes Kepler proposed three laws of planetary motion. Kepler was able to summarize carefully the collected data of his mentor Tycho Brahe with these three statements that describe the motion of planets in a sun-centered solar system. Kepler's efforts to explain the underlying reasons for such motions are no longer accepted. Nonetheless, the actual laws themselves are still considered an accurate description of the motion of any planet or any satellite. Kepler's three laws of planetary motion can be described as follows. The path of planet about the sun is elliptical in shape, with the center of the sun being located at one of the focus, which is also known as the law of ellipses. The imaginary line drawn from the center of the sun to the center of the planet will sweep out equal areas in equal interval of time, which is known as the law of equal areas. The ratio of the square of the periods of any two planets is equal to the ratio of the cubes of their average distances from the sun, which is known as the law of harmonics. So let us first understand the Kepler's first law, which is also known as the law of ellipses. Kepler's first law, sometimes referred to as the law of ellipses, explains that the planets are orbiting the sun in a path described as in the eclipse. An eclipse can easily be constructed using a pencil, that is two stacks, a string and a sheet of a paper and a piece of a cardboard. Tack the sheet of the paper to the cardboard using the two tacks. Then tie the string into a loop and wrap the loop around the two tacks. In this way, you will be able to have a resulting shape as an eclipse when you use the pencil in the right manner. What's an eclipse? An eclipse is a special curve in which the sum of the distance of every point on the curve to two other points is a constant. The two other points are known as the foci of the eclipse. So the Kepler's first law is rather simple. All planets orbit the sun in a path that resembles an eclipse, with the sun being located at one of the focus of the eclipse. When it comes to the Kepler's second law, known as the law of equal areas, it is sometimes referred to as the law of equal areas, describes the speed at which any given planet will move while orbiting the sun. Now the speed at which any planet moves through the space is constantly changing. The planet moves fastest when it is closest to the sun and slowest when it is furthest from the sun. So if you see, when the planet comes very close to the sun, it moves fast, and when it goes away from the sun, the speed slowly decreases. Yet if an imaginary line were drawn from the center of the planet to the center of the sun, that line would sweep out the same area in the equal period of time. For instance, if an imaginary line were drawn from the sun to the Earth to the sun, then the area swept out by the line in every 31-day month would be the same. This is depicted in this particular diagram. As can be observed in the diagram, the areas formed when the Earth is closest to the sun can be approximately as wide but a short triangle, whereas the areas formed when the Earth is farthest from the sun can be approximately as a narrow but a long triangle. These areas are the same. That's the fun of it. Since the base of these triangles are shortest, the Earth is farthest from the sun, the Earth would have to be moving very slowly in order for this imaginary area to be the same size as when the Earth is closest to the Sun. Kepler's third law. The third law, sometimes referred to as the law of harmonics, compares the orbital period and the radius of orbital of the planet to those of the planets. Unlike this Kepler's first law and the second law that describes the motion characteristics of a single planet, the third law makes a comparison between the motion of the characteristic of different planets. Hence, the comparison made in that ratio of the square of the period of the cubes of an average distance from their sun is the same for every one of the planets. Hey there! I hope this video helped you to understand the Kepler's law in detail. If yes, share it with your friends and give me a thumbs up in this particular video. Also, do share in the comments which is that one law which you find it difficult to understand more, and probably I can make an elaborate video on that particular law itself. So this is Professor Miithyl Dave signing off, wishing you all the best. Bye-bye.